Let's talk about our second strategy for solving quadratic equations. The first strategy that we've already covered came from chapter 14 when we talked about factoring quadratic equations. Only certain equations can be factored, however, so we need to develop more strategies to solve quadratic equations. So the first one in this chapter is that of the square root property. The square root property is used to solve quadratic equations that have no x terms. The types of equations that we're going to look at solving could consist of a number in the front, some quantity with x in it, squared, equals another number. So inside the parentheses, this could be x plus or minus some number. It doesn't really matter what that number is. But this is the most general form that we can solve using this square root property. And we talked a little bit about this method just in chapter 17 with radicals. So now let's look at it in the context of quadratic equations. The first step that we're going to do is isolate the squared part of the equation. So for the first example, 5x squared minus 10 equals 70, the squared part of the equation is x squared. I want that by itself on one side of the equation. So the first step would be add 10 to both sides. Remember, when we're solving equations, we are undoing the operations being done to the variable. So we have to go in reverse order of operations order when we're doing this. We want to isolate that x squared, so let's first add 10 to both sides. Trying to get x squared by itself again, the x squared is being multiplied by 5, so we would divide by 5 on both sides. 80 divided by 5 will give me 16. X squared equals 16. We learned in chapter 17 that we can take the square root of both sides. And if we take the square root of both sides, because it's an even root, we need to make sure that we put that plus or minus in the front. That's coming from that absolute value of x when we take the square root. Square root x squared should be the absolute value of x, which gives us those two answers. And then the square root of 16 is 4, so x is equal to positive and negative 4. And we have two answers. Keep in mind those two answers are present in that plus minus that are there. In problem number 5, we're still going to isolate that x squared term. I would like for you to pause the video at this point, try this problem on your own, and when you resume, I'll have the answer for you. But remember, try it on your own first. Don't just copy what I have down. Make sure that you can apply what you've just learned to this new problem. And for number 5, did you get plus or minus 4/5? Good job. If you didn't, you can either pause the video and review my steps, compare them to yours, and see where the mistake happened. Or if you'd like, pop on over to that OneNote and take a look in this section for collaboration 22. For problem number 6, notice this one's a little bit different, but the idea is not. Just like before, we need to get the thing being squared by itself on one side of the equation. So I'm going to first add 9 to both sides. 16 plus 9 will give me 25. X minus 3 squared equals 25. I need to take a square root. If I take a square root on the left side, I get x minus 3. Taking it on the right side, introducing the square root, I have a plus or minus there. Plus or minus square root of 25 is equal to plus or minus 5. So I have x minus 3 equals plus or minus 5. I'm not done. I need x completely by itself. So we can add 3 to both sides. Here's where it can get tricky. We have to be careful. On the left, I have x. X equals. On the right, I have plus or minus 5 plus 3. I cannot add that 3 into the 5 and get 8 plus or minus 8. That's not right. I have to look at these as two different problems. Positive 5 plus 3 and negative 5 plus 3. When I'm adding a positive and a negative number, I don't get the same answer as when I'm adding two positive numbers together or two negative numbers together. So on the top, 5 plus 3 will give me 8. Negative 5 plus 3 will give me negative 2. So those are my two answers for x. We won't always land with nice, pretty whole numbers like these examples are. As we saw in Chapter 17, we would keep the answer in a simplified radical form. Let's talk about how to solve an equation for a variable. In example number 7, we have w equals 16x squared. I want to solve this for x, so w equals 16x squared. I need to isolate the x squared part. We'll start out by dividing by 16, and we get x squared equals w over 16. Then I need to take the square root. Square root of x squared will give me x. Square root on the right, plus or minus square root w over 16. W does not have a perfect square, so we'll keep it as square root w. 16 does. Square root of 16 is 4. So x equals plus or minus square root w divided by 4. So we could write, just to write it concisely, x equals plus or minus square root w over 4 would solve that equation for x.